Okay, so today is going to be exercise week. We're going to finish up this last chapter, then we're going to do some exercises together. Okay, I mean last question, not last chapter. Okay, if you look at this question here, it says that in an experiment, the forces are applied to a spring as shown in figure 2.1. Okay, there are some forces here applied to this spring here. The result of the experiment is shown in figure 2.1b. Okay, so you can see that clearly this line here goes straight all the way up until this specific point. Oh, this is the P. This is point P. Okay, it goes up all the way until this specific point. Then you can see that it starts to curve here, guys. As soon as you start curving in the Hooke's Law's graph, what does that mean? Yeah, this part here should be the elastic limit, right? Anyways, hey, flip to this page, right? We're going to discuss this answer here. It's about the Hooke's Law. Yeah, one more flip. Yeah, this page. Okay, yeah. Then we're going to be doing exercises today. Okay, so anyways, shit, where was I? Okay, right. So there's the weight here pulling it downwards, and then you can see that this part here starts to curve. Like I mentioned, guys, as soon as it starts curving, this indicates that this is the elastic limit, meaning to say this part here no longer obeys Hooke's law. This part here obeys Hooke's law, right? So this is the first thing you have in your mind. Then after that, the first question is, they ask you, what is the name given at point Q? Obviously, the name is called the elastic limit. The point of maximum elastic limit or whatever. What? Oh, never mind. I should say elastic limit. The same. Okay. Then after that, they say that for part OP of the graph, the spring obeys Hooke's law. State what this means. From O to P, it says that it obeys Hooke's law. This part here, the part obeys Hooke's law. So whenever we talk about Hooke's law, I told you before, right? We can actually describe it using the graph itself. Do you still remember how to describe Hooke's law?
The force will be directly proportional as long as it hasn't reached its elastic limit.
Directly proportional to what? Close, not exactly what I'm looking for, but very close, right? Pay attention, guys. I repeat this again. Now, Hooke's law states that the force is directly proportional to the extension. To the extension, bro. To the extension, right? Provided that the elastic limit is not exceeded, right? In the notes, you'll see a different description, but it's essentially supposed to be the same thing. You see here, Hooke's law states that the extension, which they start from here, of a spring is directly proportional, which is here, to the force exerted onto it, provided that the elastic limit is not exceeded. So based on the graph itself, you can already describe Hooke's law already, which is essentially what this question wants from you here right now. They want you to state what is meant by Hooke's law. So you're going to say the exact same thing. Hooke's law states that the force exerted on a spring is directly proportional to the extension, provided the elastic limit is not reached. Provided the
one and the two does.
What?
There are two does.
Where?
And after that.
Good. That was a test. You pass. Phil, why not?
On Sundays for the day,
Oh yeah.
Oh, is it? I don't know.
Tomorrow's the next is like the function.
Oh, really?
I'm Muslim, but I couldn't give lessons.
Good. Because there will be no holiday. There will definitely be no holiday.
No, there is actually.
No, not from here.
Ah.
We'll still have to come here.
But for my school, it's a holiday.
Oh, then yeah, maybe at school is a different story. But here, no. The only holidays you get to enjoy here are the 5 weeks or Chinese New Year, Deepavali, and Hari Raya.
Even Christmas.
Christmas usually we don't have Pasar. December. December usually we're closed for half a month. Yeah, like so then. Okay, then.
Last time I was wearing jeans here, but and then this today I decided to wear shorts. Now I regret wearing shorts.
It's cold. I think it's cold too, man. I've been feeling cold the whole day actually. 27 degrees. Ah. Okay, then after that, this next question here. The spring is stretched until the force and extension are shown by point R. Okay, by point R, which is here lah, this point R here lah, right? On the graph, compare how the spring stretches as shown by the part of O to Q with the part Q and R. So O to Q is this part and Q and R is this part, right? You're gonna compare how they stretch lah. You're basically gonna say that during O to Q, the springs during OQ, the spring stretches. Oh my god, this is how I spell stretches. Missing a T. Stretches proportionally with the force exerted. Then QR, it does not extend proportionally anymore.
Okay.
Yes. Oh, it's okay. It is not an English exam, but the scientific names you must spell it correctly. Meaning to say, oh, it doesn't matter. Like Hooke's law, right? If you write HOKE, it's wrong. But if you stretches, right, you write, even if you stretch, you spell this with a K, it won't be wrong. They will not penalize you for the spelling errors, but the scientific names you must write it properly. Scientific names you must write it properly. Okay.
I think that thing on the screen looks big, but when I write it in my book, it never fits for.
Okay.
No, I meant like when it's on the screen, it always looks big, so I think I can write big, but it never actually fits the line.
Oh.
Yeah. You were.
Going already. He's done the counters. I don't go back together. We don't even stay together. Yeah, we talk again. No, we stayed together for the longest time, like for 28 years. Yeah, that's been for already. Sick of it.
Hey, to be honest, I wouldn't be surprised. You ready to see the same face for every time we come? Yes.
Yeah. So we had to share the same room for the longest time. Yeah, bro. You think have so good at our own room? It's just sad, man. I've been sharing room with him for. Yeah. It's not an issue. I've been doing that ever since young. Okay, last question. Okay, the part OP of the graph shows that the spring stretching according to this expression F equals to Kx, which is essentially Hooke's law's formula, right? Use the value from the graph to calculate the value K. You're supposed to use the value of the graph, guys. So hey guys, let me tell you this. Whenever you're dealing with graphs, the year 11s, they know this, but since you guys are new, listen up. When you extract information from the graph, you cannot suka hati and pick any point of the graph. when you pick any point in the graph, it must always hit the grid exactly on the cross. Hit the grid exactly on the cross, meaning to say these points here, right? This point here, this point here, this point here, or whatever point here, right? You cannot use this information. You cannot, guys. So having said that, if you're supposed to use the proper points here, I think this one will be a perfect fit. This one will be exactly 4, and then the extension will be, I think 1, right? Yeah, 1, 2, 3, 4, 5. Yeah, 1, exactly 1 here, right? But bear in mind, this is in newtons and this is in mm, meaning to say when you write your answer down, you know that F equals to kx, right? So k would definitely become F over x, right? You're supposed to write 4 over 1 mm, guys. So your final answer will be 4 Newton per mm. 4 newtons per mm because the graph gives you in mm, guys. That's what I'm talking about. And then bam, you get free 2 marks, easy. Okay. Okay. All right. Neonica, if you're done with these questions here, please whip out this exercise and start doing the ABC questions first. Please do until question 14. Do until question 14, guys. I'm going to give you 20 minutes to do this, or maybe more. But we're going to discuss answers as we go on. Yeah. I start doing this question 1 to 14. Yeah.
Yeah.
What? Next, it's starting again, probably. Why do you always not bring food? That's school, not me. Don't you?
I just eat back one big deal.
You better start bringing it here because I can guarantee you'll need it here. Okay, Neonica. Start doing until question 14. Yeah, we'll discuss the answers in exactly 20 minutes. Starting from 20 minutes, guys. Neonica. Are you done with the questions already? Which question are you at?
I'm doing question 11 now.
Sorry?
I'm doing question 11 now.
Oh, 11 is it? Okay, I'll give you guys 5 more minutes to attempt the reading because they're not done here as well. 5 more minutes, guys, then we discuss the answers. Okay, everyone, I hope you all are done with the first 14 questions. Let's go through it one by one, guys. Okay, if you look at the first question here, a spring is stretched by hanging a piece of metal on it. Which name is given for the force that stretches the spring? Is it called friction, mass, pressure, or weight? Now, some of you guys may circle mass as your answer, guys, but note that force is measured in newtons and mass is actually measured in kg. So obviously the answer is not mass and instead should be weight, guys. Very, very important. Yeah. And after that, which object has the greatest weight? So if I look at here, they say that these are all the masses, right? And I have all the gravitational fields here. The formula for weight, W is equals to mg, right? Meaning to say, if I want the greatest, whichever one multiplies to become the greatest, that will be the answer, right? This one here will be somewhere around 150. This one here will be somewhere around 195. Oh, wait. Yeah. Then this one will be somewhere around 180, and this one will be somewhere around 150. So clearly the answer here is going to be boiler, right? Right? Then this part here is a moment question. What do you write for this, Macy? What's your answer?
C.
Oh, very good. How about Evan?
C.
Oh, very good. Everyone has a good understanding of this already. So if you look at this question here, a uniform beam XY is 100 cm long and weighs 4 newtons. If they weigh 4 newtons, where should these 4 newtons be acting on? Where should these 4 newtons be acting on?
Center.
The center, right? Because weight acts at the center of mass, right? And it says that the beam rests 60 cm from the end. This 60 cm is from here to here, right? So this pivot is resting here. A load of 8 newtons hangs 10 cm from X. So 10 cm away, you have this 8 newtons. The beam is kept balanced by a force F here, right? This force is keeping it balanced on the 80 cm mark. What is the magnitude of F? Obviously, this one here, we're supposed to use which concept? MIE. Yeah, very good. Don't start off with that. I'll start off with understanding that it is moments in equilibrium. Guys, I say this a lot, right? Moments in equilibrium states that the total what? Anti-clockwise moments must be equal to, yeah, total clockwise moment, right? In this scenario here, this 8 newtons is clockwise or anti-clockwise?
Anti-clockwise.
Yeah. How about this one? How about this one?
Clockwise.
Clockwise. So I know I have 2 anti-clockwise, right? So the formula will be F1 D1 plus F2 D2 is equal to F3 D3, right? Make sense? Right. From here, just substitute all the information, it's going to be like 8 multiplied by how much? 10, 50, because there's always distance to the pivot, right? Right. So this is my first one, plus my F2, which is the weight now. The weight is 4 newtons. Multiplied by my distance. How much is the distance? 10. It should be 10, correct? Why? Because it's the center, right? It means to say it's the 50 cm mark, right? If here is 60 cm, it means to say here to here is 10, right? Right. It's equals to my F. I don't know how much is my F, but I know the distance. How much is the distance? F to the pivot is 20, right? So from here, it's just a matter of algebra, right? 400 plus 40 is equals to 20F. It's equals to 20F. From here, 440 divided by 20 will have been your F, right? if you press in the calculator, will be exactly 22 newtons. Very good, excellent job.
Again, I got the answer right, but again, I forgot to write the formula.
Evan, if you don't write the formula, you're not going to learn anything here. Make sure you write the formula. I keep saying this over and over again. Okay. Okay, then after that, this one here. This one is straightforward, easy. What's the answer? Which one is low, stable one? Definitely boy, because the center of mass is low and the base is wide, guys. The base is wide and the center of mass is low. That's why obviously B is the answer here. Then this one here is, you actually need to measure this, guys. You need to measure this according to the scale that they give you here. It says that the diagram shows a incomplete scale drawing to find the resultant of 10 newtons acting on the point shown, right? So this is 10 newtons, 10 newtons. What is the magnitude of the resultant force? First question, which direction is the resultant force? Right, in between these two forces, right? So what you actually have to do is you need to measure how long this thing is. How long will this thing be? Okay, measure that. Chinese, it's not a guessing game. How long is this thing? 2.49. 2.9 cm. 2.9 cm represents 10 newtons. Okay, this is my scale, my calibration. Then after that, you measure this length here. You measure this length here. How long is this thing? .2 cm. If 2.9 cm represents 10 newtons, then 5.2 cm represents how many newtons? Use your calculator, play the ratio. I think you should get somewhere around 17. Is it?
17.91.
Yeah, I think you should get 17.9, which will give you ultimately 18 newtons. Correct to two significant figure.
Yes.
Do you guess this correctly as well? It's not a guess, well, especially when they give you these kind of scales here, you need to yet again go find the scale first. With the scale, you know that this is your resultant force, right? This direction is your resultant force. So you just need to measure how long it is only. Then you'll get your answer already. Okay. And question 6.
But if question like this, use a ruler.
Yes, you must use a ruler. That's why you need your calculator and your pencil box. Right. Okay, then after that, question 6 here. Question 6 here is a bit harder. It's a relatively tougher question. Let's go through it together. It says that a tennis ball is 0.06 kg, travels horizontally at a speed of 25 meters per second. So this is my mass, right? And this is my initial velocity, right? The ball hits a tennis racket and rebounds horizontally with a speed of 40 meters per second. This is my final velocity, right? The ball is in contact with the racket for 50 ms. What does 50 ms mean, guys? Milli what? No, definitely not. Meters. Millisecond is correct. Yes, it is actually milliseconds. Millisecond means to say it's 50 times 10 to the power of -3 seconds, guys. Millisecond is divided by 1,000. Or if you if you want to write it, it could be 0.05 seconds as well. Right, millisecond is like millimeter to meter, that kind of scenario, right? So from here, if I understand it's 0.05 seconds already, they right now ask me for force. Okay, what's the force formula that you have learned already? F equals to? No. Bloody hell, kx, this one is spring. Yeah, F equals to ma, right? So you need the mass. Okay, then you look here. Oh, I realize that I have the mass here. How do I find the acceleration? What's the formula for acceleration? Yeah. So you find the acceleration with this formula first, substitute it in, multiply the mass, and you'll be able to find the force. Try to do this first, everyone. Do this right now. Most likely you'll do it wrong if you do it the normal way, but I'll show you why. Oh.
You're wrong.
Definitely wrong now. But negative how much?
420.
Don't even have the option here.
16.633.
Okay, everyone pay attention now. When you deal with these kind of questions here, first and foremost, because there's so much information, right? It is a must. Guys, make it a habit right now. I've said this for many times. Make it a habit to underline the information, because I can guarantee you, as you do more calculation, you are going to lose one or two useful information here. So you always underline it. Even right now, when I'm doing a new question, I will also underline all the useful information, regardless of I would say I'm definitely much better than all of you guys are, but I still do that because it actually helps with your calculation later on. So from here, the first thing is most students, this is what they'll do. They'll know that this is the final velocity and this is the initial velocity, right? So they'll just straight away take 40 minus 25, which is wrong already straight away. Why? Because guys, pay attention now. Velocity is a vector quantity, guys. Velocity is a vector quantity. Yes, because it has direction. Usually, if I associate the right with positive, right, the left must be negative. It doesn't matter which one you associate, positive or negative. You could also say that the left is positive, then this one will be negative. Okay, because they are in opposite directions. Once you understand they are actually in opposite directions, when you do the calculation, if let's say you say that this is positive and this is negative, you could either go negative 40 minus 25 over your 0.05, or you could associate this as positive and this as negative. So you'll get 40 minus negative 25 over 0.05 to find a calculation. Okay, and when you do that, right, I would prefer to do this because I don't want a negative value, right? It will be 60 divided by 0.05. Then you take this and you multiply by the 0.06 of your mass. Do that right now. Tell me the answer.
32.4.
What? 32.4 is acceleration, is it?
Wait, no. 40.
No, I want the final answer. The force. 78. 几个是什么 ？Evan? You get 78 too? Do you know how to do it or not? This is just the acceleration. You're looking for the force. No? Okay, copy this down if you understand. If you don't understand, you better ask until you understand. Which part? Times by 4.
The force.
The force is F equals to ma, right?
Yeah.
This is just this part, right?
Yeah.
You need the mass part also, right?
Yeah.
How much is the mass? Wait, how much is the mass? Bloody hell, I even highlight it for you already. 0.06, right? Whatever you find here, you multiply by 0.06 and you'll get your force already. 78, man, wasn't it 18? Which, give me the calculator. 65 divided by 0.05 multiplied by 0.06.
Yeah.
That's correct. It is. Sorry I doubted you. Okay.
这个我们 share 不一定的。 see favorite by Tuesday.
Feel very ready.
Wait, what's happening? 78. I started at 32.
What's the calculation? Do you know how to do this or not? 40 minus negative 25, how much is that? Then you divide by 0.05, right, to get your accelerating. Yeah, but this is not the final answer, right? Oh, what are you doing, Evan? Okay, understand now this part is very important. Copy down everything if you understand already. From here, this question is basically introducing you to the fact that velocity is a vector diagram. It's a vector quantity. And because it's a vector quantity, it will either be positive or negative depending on the direction. But it usually just be one, not two.
When I just realized, I guess just now I'm still looking for it.
You will definitely not be so lucky in the real exam, so you better learn how to do it really. Okay, everyone. Then moving on. A body of mass m has a weight w in the location where the gravitational field is g. Looking at this information, I know it's going to be w equals mg already. All right. Which statement about these quantities is correct? M and w are both forces. No. M and w are both vectors. No. M and w are related to the equation. W equals to mg. Most likely, m and w have the same unit. This is dumb. This is like literally 3 marks. I don't want to explain this one. Okay. Then after that, the next part here. This one here is the understanding of how moments work, guys. If you look at this question here, an object is pivoted. Whenever you see the word pivot, for sure, 100% is going to be about moments already, right? Which is force times distance at point P. At point P, I mean to say this is your pivoting point. At point P, right? A student ties a length of string to a peg on the object. He pulls the string with a force F. Okay, he pulls a force F here. Okay, this is your force. What is the moment of the force F to point P? Guys, if you're talking about moments, what's the formula for moments again? What dictates a moment? What and what?
Something times 50.
Something times what? What times what?
Okay.
Yeah, very good. It's force times perpendicular distance, right? Yeah. This force, the only one that is perpendicular is this one, right? This is sure and hell not perpendicular, not perpendicular, and not perpendicular, right? So that's why the answer can be no other than C. Yeah.
That's right. I don't guess it. I think I remember that first
Yeah. Good. Maybe you can be better than your sister.
Yeah, I know what I'm going to learn, but I just forget how to do it.
You know why? Because you're not doing a homework or exercises enough. For sure, you don't have application. You know the concept only. Same thing for physics also. You must do the homework. Yeah, but so far you guys have been doing it now. So, talking about this, right? Man, given we say this batch, your batch onwards, right? If we find that any one of you guys are not doing the homework and being difficult, right? We'll get out here. Don't waste time. We cannot help it. We don't want to waste time on the students that don't help themselves anymore, especially after the MCO and everything, right? So me and Gilbert, we are very, 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 very firm on the exercise that we give. If you're not doing it 1 time, 2 times, okay, normal, right? But if it's like a continuous thing, just get out of here. We can't help you. Wasting our time, wasting our parents' money as well. That's what we agreed upon. So don't you dare not do my work. But so far you guys have been doing it, so I'm really glad. Good. I'm certain this year the results will be different for everyone. Oh, I tell you why it's different now. Because last year during MCO, right, half of the students were online, half of the students were here. The online students, because it was MCO and they were stuck at home, right? So they're not really yeah, focusing, and then it was new also lah back then. So they're like, oh, no need to do I had one student MCO for 80% online, right? When she came to the physical class, her book is empty, 80% empty.
What are you?
What were you doing? Then I can only assume she was sleeping. Then I'm like, okay. Then soon enough,
On Zoom.
yeah, just Zoom and then sleep already. So soon enough, I know for sure she's gonna drop it, and true enough, she dropped the subject like 3 or 4 months before the exam, which was no surprise, right? So, in conclusion, you must help yourself because we can definitely help you if you want. Okay, anyways, back to this here. Each diagram shows a metal plate with 4 parallel forces acting on it. These are the only forces acting on the plates. Which diagram is in the plate, which is in equilibrium? Guys, what's the condition for it to be in equilibrium again? Yeah, everything should be the same, right? Now, if we know that everything should be the same, you could argue and say that, hey, actually here is 3, here is 3, here is 3, here is 3. This in 3, here is 3, and obviously this one is not equilibrium, right? So you could say that A, B, and C are actually the same, but only C is the answer. Why? Yes, it will actually cause it to rotate. If you look here, this 2 newtons and this 2 newton will obviously generate a greater moment compared to this 1 newton and this 1 newton here, right? And because of that, this thing will actually spin in the anti-clockwise direction. Same for this one as well. This one here will generate a greater moment compared to this one here and this one here, right? So obviously this thing here will actually spin in a clockwise movement.
That one can spin the clockwise because they're all pretty much equal rate.
Yeah, especially when you spin it, then it balances itself. Just like I mentioned, the bicycle, if you ride those 2-wheel bicycles, as soon as you move, you'll be balanced, right? Because there is balance in motion. It's called if I'm not mistaken, I think it's called gyroscopy. I can't remember the exact term already, but there is. I'll show you a video later. It's a very interesting concept that shows that any object in motion is in balance. A very interesting concept. Yeah, it is exactly that.
So even if you follow.
Obviously, if something hits you, you're going to fall over. But I'll show you the science behind. Let me finish this one first. The diagram shows the vertical forces acting on the ball as it falls vertically through the air. The ball does not reach terminal velocity. What's the condition to reach terminal velocity again? Yeah, the upwards must be equal to your downwards, right? And if they say this, it means to say obviously the downwards is more than upwards. Okay, with that information in mind, which rule describes what happens to the resultant force on the ball and what happens to the acceleration of the ball as it falls through the air? The resultant force, will it increase? The acceleration, will it decrease? And why? First, let's talk about the resultant force. Will the resultant force increase or decrease, and why? Why will it increase?
Because more and more force will be applied when gravity goes down.
No, the only force acting on it will be the weight.
Other weight, not other.
Gravity will be the same regardless of where you go, right? Meaning to say,
The weight. Yeah, I know I just don't know explain it.
or you may see increase or decrease resultant force. Why? Yeah, no, it's because the air resistance, as this thing continues to drop, I know for a fact that the downward force is stationary, is constant already. Because no way in hell you're going to add weight somewhere mid-air, right? So don't talk about the downward force, right? For sure stationary already. But I know for a fact that this air resistance is actually going to increase over time, right? Why will the air resistance increase over time?
The more resultant force, the more resistance.
No.
The more.
How do we relate air resistance? No. How do we relate air resistance with something falling?
Okay.
Cycle back already. No, fools. The air resistance is directly proportional to your speed. As it keeps falling, obviously what's going to happen is the speed is increasing, right? As the speed increases, the air resistance will increase also. That's why your resultant force and your acceleration is supposed to decrease, because in this scenario, in the first scenario here, let's imagine here is 10 newtons and here is 50 newtons. The resultant force is 40, right? Then it's going to accelerate. As the air resistance build up, this one becomes 20, right? Means to say the resultant force becomes 30, the resultant force becomes 20. As the air resistance grows, the resultant force decreases. When the resultant force decreases, obviously, according to your F equals to ma formula, the acceleration is going to decrease, right? Because no way in hell your mass is going to change, Namo. Right, so that's why your answer is going to be A, guys, for this one here. You understand? Next question. On the moon, all objects fall with the same acceleration. Which statement about explaining this? The weight of an object is directly proportional to the mass. Possible? Not possible? No. No. Yeah, C is the only answer here. The weight is directly proportional because yet again W equals to mg. Since the gravity is constant, this one increases, this one for sure increases. Yeah. Okay. Last 3 questions. A pair of cutters is used to cut a rope. Where should the rope be positioned and which label point should the hand be positioned to produce the greatest cutting force? If you ever struggle with the scissors before, where will you put the object? Will you put it closer or further away to cut it? You put closer, right? Why will you go closer? Why closer will cut it better?
Common sense.
It's more like 这样
I can explain it. Yeah, you could say there is more force generating here as you go closer to the pivot. Why? Because let's imagine for ease of calculation, let's say here right now is 2 meters. Okay, and obviously your handle you're going to put an S right? There's no doubt about it. Let's say the force here is 20 newtons. This clockwise closing effect causes a 40 Newton meter, right? Right. Let's put this into calculation. I know that this moment here will be this moment here. Right? Can you imagine it or not? This closing effect here will generate this closing effect here. Right? So anti-clockwise equals to clockwise. Let's imagine today I put the force here versus the force here. This distance is obviously longer. Let's say it's 20 meters. Not 20 shit. Maybe 4 meters. Right? And then this one here is obviously shorter. Let's say this one is 1 meter. Today, right, if I make this into calculation, my clockwise movement is already this, right? Clockwise movement must be equals to your anti-clockwise movement, right? In other words, force times distance must be 40, right? This distance here is 4, right? This 4 will only generate 10 Newton force only, whereas this distance here is 1. It will generate a 40 Newton force here. Can you see through calculation why we will instinctively put the object closer? Because because with a closer object to the pivot, I actually generate a greater force. Do you see this or not? So obviously it's supposed to be Q and S. Donkey. Okay, and the final question here. The lamp in the diagram. Oh shit, dated. The lamp in the diagram is not very stable and falls very easily. This one is dumb, right? It's 3 marks. The obvious answer is D, right? I don't want to explain this because it's 3 marks. Then the final question here, I can see this one here is similar to the one we did just now, right? You have the first information, which is your mass. E decelerates from, so this is your initial and this is your final, right? Right. And then the force of F here. How long does the force X? You're looking for the time, right? What formula should we use here? Yet again. You have M, you have F, V, U, and T. What? We're looking for time. What should we find? Look at V and U, obviously there's only one formula to use, right? It's equals to your acceleration, right? But the question here is, I have V, I have U, I don't have A, and I'm looking for P. Yeah, I need to find the A first. Good. Good. Then with this, I can find it already, right? This will be 5, this will be 20 minus 50, this will be my T. So essentially, it's going to be like 30 over T, or negative 30 over T, if it goes to 5, right? So your answer should be no other than C, right? It doesn't matter if it's negative or positive, guys, this one here. It doesn't matter. Because this is essentially yet again change in velocity. Yeah, everyone. This part here is very important. Our calculation always comes up in the exam one. Okay, guys, see all these other things here? We'll discuss the answers next week. What video did I say I wanted to show you guys again? The very interesting one. Oh, the gyroscopy one. Yes. Let me show you.
Yeah, watch the video. I'm going to take a shit on that.
Oh my god, go, please go. Gyroscope. This video. Gyroscope tricks. Really stuff. Oh, actually, watch this one even better. Gyroscope space. This out, check this out.
And yes, I'll just get this gyroscope here. And it's just a toy gyroscope, really. But of course, in zero gravity, if you knock it, it's going to tumble, it's going to move around like any object up here does. However, if I get this spinning, just give me a second.
He's in space. Check this out. Once you start spinning the gyroscope, a very interesting thing happens.
So once the gyroscope is spinning, you can just see how stable it becomes. And however I knock it, it's not going to change its plane. It's going to remain in the same plane. I can put it physically into a different plane and tap it again, but it will still hold that same plane, and it's much more stable. So it just gives you an idea of how we use spin stabilization and gyro stabilization for control on board the International Space Station.
You see that, right? You see the differences now? Before you spin it
I'll just get this gyroscope here, and it's just a toy gyroscope, really. But of course, in zero gravity, if you knock it, it's going to tumble, it's going to move around, same plane, and it's much more stable. So it just gives you an idea.
Because there is stability in motion. It's the same concept like why your bicycle, your two-wheel bicycle, not the four-wheel one, two-wheel bicycle, if you're in motion, you won't fall. But if you stay still and you try not to put your legs on the ground, you'll fall, right? The concept here is roughly something like this. Imagine today, this is a bicycle. Okay. Oh shit, oh, very hard to draw. Okay, I'll show you through the videos, okay? So imagine this is a bicycle, right? This is the front of the bicycle and this is the back of the bicycle. Without you moving, what's going to happen is, right, actually this bicycle will be subjected to forces, right? It could topple this way, it could topple this way, or it could go forward, or it could go backwards. But once you start moving, right, what happens is your forward velocity is greater than your velocities on the left and the right. And because your forward velocity is greater, right, your bicycle, even if it tilts a little bit down, it will balance itself back up, right? Because the forward motion is greater than the left and right motion here. You get what I mean? Gyroscope is working on something similar like this, but gyroscope is much more complex because gyroscopes is playing with the force, the centripetal forces. When an object spins like this, all the forces are balanced in all directions. It balances in all directions, right? That's why it is able to achieve stability. It essentially is like forcing the forces to push in all directions as it continues spinning and spinning and spinning and spinning and spinning. So gyroscopy is actually a very, very, very interesting concept. You can even watch this guy do the precision on the gyroscopy here.
Hey everyone,
Interesting
it's me,
concept on
Derek,
gyroscopy.
from the channel Veritasium. And I've been following this series by Destin on Smarter every day about helicopters, and gyroscopic precession is just one of those things that still blows my mind as it did Destin's. So I'm here at the University of Sydney, my old stomping grounds. I'm going to borrow some of their lecture dem equipment to hopefully teach you a bit about how gyroscopic precession works.
The first thing I need to do is talk about vectors, because a lot of things in physics are vectors. That means they have direction. So an example would be momentum and force. Those are two examples of some pretty common vectors. So if I have a cart moving along here, it has some momentum in that direction, and if I apply a force to it, I can change its momentum. So for example, if I push it to the right, then its momentum will increase to the right. It all makes a lot of sense. Well, there's a similar statement we could make about rotating bodies, which is that a torque increases the angular momentum of an object in the direction of that torque. So let's try to figure out those terms. If I apply a force down on this side of the wheel, I create a torque. Now, torque is force times the
torque is movement by the wheel. Same thing. Torque and movement is the same thing.
distance from the rotating axis. You could call it r. So torque is the force applied times the radius away from the turning axis. Now, what's the direction of that torque? Well, we actually use a right-hand rule to define this. And so what you do is you put your fingers in the direction of the radius from the turning axis and curl them in the direction of the force, and your thumb points in the direction of the torque. So the torque is actually out this way at 90 degrees to the force. The force is down that way, but the torque vector is actually pointing out this way. So the angular momentum of this wheel is being increased in that direction. So the more I apply this torque, the more I increase the angular momentum of the wheel in the direction of the torque. So I'm making this wheel have a very large angular momentum out towards the camera, out towards you. Now, before I go any further, let's have a look at this setup that I've got. I have a wheel here hanging from only one side by this rope. And so right now there's actually a torque on the whole system if I let go, because the weight of this wheel is pulling down, and that force is applied at this distance away from its pivoting point there. So if I let go, well, it does exactly what you'd expect. The wheel swings down this way. But I want to see that as an example of rotational motion. There's a torque which is pointing out this way, which is trying to increase the angular momentum of the system in that direction. Now, angular momentum in that direction requires that the whole system starts swinging anti-clockwise. And so that is what happens. But what happens if I only let go after I've already spun up the bicycle wheel? Well, in that case, the bicycle wheel would already have angular momentum this way, and so a torque pushing that way actually swings this angular momentum round that way. Okay, so let me try to get the wheel spinning and make it work. Come on. Oh, look at that.
You see that?
It's rotating as we predicted. See, the angular momentum vector is pointing out this way, but torque is pushing it this way. So angular momentum, torque, and torque is pushing that angular momentum vector around.
This is essentially the circular.
Except not for long, because
you guys have talked about.
this appears to be a
One
quite
force in this direction, one
frictionful
force in that
wheel.
direction, cause it to go
So
circular
check
motion.
out Destin's other videos about helicopter physics, and then come check out my channel, Veritasium, where you can find more like this. Except I don't often nearly get my head cut off by a bicycle wheel. So.
Interesting, right? With the power of physics, you can explain a lot of very weird concepts and very, very interesting things. Okay, but having said that, I'm going to leave you guys with that. Please make sure to do all the exercises from this homework here. It is very crucial for your understanding. Then after that, next week we'll discuss answers and then probably move on to a new chapter after we're done with the discussion. Okay? Yeah, that will be it for today. I'll see you all next week.
Thank you.
Welcome. Bye bye. Needs to take a huge dump, I will assume.